Hi, welcome. Thank you for joining us today for the WeSys webinar on Let's Crack Passwords. We're super proud and excited to have WeSys strategic partner Carnegie Mellon University Software Engineering Institute here with us today. So we have Marissa, Destiny, and Chesalia. And I'd like to first, before we dive into this fantastic webinar, I'd like to first do a little introduction to the WeSys organization. My name is Lynn Dome, and I'm Women in Cybersecurity Executive Director. We often go by our acronym WeSys, W-I-C-Y-S, like we, sis, like sisters, because that's exactly what we are. We're a cyber sisterhood. And we're a 501c3 member-based nonprofit. We have over 5,000 members and have representation in over 70 countries. We also have 40 professional affiliates all throughout the world in Africa, Australia, Canada, France, India, Pakistan, the UK, and throughout the United States. And 130 student chapters in Canada, Costa Rica, India, Nigeria, and the United States. And our mission is to recruit, retain, and advance women in cybersecurity. And we do so by creating opportunities. So since we're a member-based organization, we naturally have an online member forum where there's many different special interest groups, such as neurodiversity in cybersecurity, Latinas in cybersecurity, cybersecurity law, data privacy. So you could either start your own special interest group, whatever topic and conversation interests you, or you could join an existing one. We have many different skill development training programs, such as the Security Training Scholarship made possible by Google, Facebook, and Bloomberg. AWS builds out a roadmap. Target funds gamified cybersecurity challenges. SANS Institute offers many different types of certifications for the WeSys members, and we have many, many more training programs. We have newsletters and webinar series, scholarship grants and awards, not only for our conference, which is coming up March 17th through the 19th in Cleveland, Ohio, but also for other conferences. Speaking of our conference in Cleveland, WeSys 2022, our applications for scholarships, grants, and awards are open right now until October 18th. And then in addition to that, our call for participation is also open till October 18th. We have the Cyber Talent Emergency Fund designed for students within their last 4 semesters of graduating from their cybersecurity program. If they have a true financial emergency, like a medical expense, or they can't pay their electrical bill or their car breaks down, they could apply and receive up to $599 within 48 hours. We have speaking and media opportunities because we want our members to be what others can see, to showcase their talent, to put themselves out there as the cybersecurity professionals that they are. We have a Job Board Plus Plus where all our members update their profiles and upload their resumes and get recruited from, and all our strategic partners recruit from there and also post their job. We have an apprenticeship program, an internship program. We participate in market research. We have leadership summits, virtual and in-person career fairs. We have assistance programs for veterans, military spouses, and a speakers bureau. We also have a mentor-mentee program. For the second year in a row, we have over 100 enrollees. That program is designed to upskill and uplevel women no matter where they're at in their career, preparing them for their next level of advancement. So it's a 12-month structured framework, and we developed the curriculum for that. We also have a racial equity committee designed to lead us with inclusion and allyship and equity. And we owe all of this as a special thanks to our strategic partners, AWS, Bloomberg, Carnegie Mellon Institute, or Carnegie Mellon University Software Engineering Institute, which brings us our webinar here today. We also have Cisco, Facebook, Google, Lockheed Martin, Microsoft, Optum, AbbVie, JP Chase and Company, LinkedIn, Navy Federal Credit Union, Nike, SentinelOne, Wayfair, Workday, Accenture, American Airlines, Arctic Wolf, Dell Technologies, Envestnet, Flatiron, Fortinet, Haystack, Here Technologies, The Home Depot, IBM, Indiana University, MITRE, Motorola Solutions, Oak Ridge National Lab, Palo Alto Networks, Salesforce, SANS Institute, SAP, SmoothStack, SpearTip, Starbucks, Target, University of California, San Diego, and Verizon. And so we have our webinar here today, and we have this fine group that's here to ask questions. So I encourage you throughout the entire webinar on the bottom of your screen to please ask questions, and we'll be sure to answer those. And if you haven't done so already, please join us. We're all over social media. We have a membership and it's on our website, wesis.org. And we also have a subscribe form to our newsletter so you never miss a beat with all things that are going on with the WESIS organization. So with that, and without further ado, I'm going to go ahead and get started in our presentation today.
Hello everyone, welcome to Let's Crack Passwords. But before we get started, we have to show our distribution statement for a few seconds. All right, moving to our agenda. So we'll be going over common mistakes people do, 5 steps on how you can crack passwords, cracking attack scenarios, and password best practices. My name is Destiny Plaza. I'm a cybersecurity engineer.
I'm Marissa Midler, and I'm also a cybersecurity engineer.
My name is Chesley, and I am your resident hacker and penetration tester. So a few years ago in 2018, Hawaiian residents received a text from the emergency alert system warning that there was a ballistic missile that was incoming. But this miscommunication wasn't the alert that sent the larger InfoSec community blasting the event on Reddit and other forums. There was an Associated Press picture that got out of an operations manager proud of his setup, but unbeknownst to him, there was a sticky note with the password to a system within that alert system. So common things that people have and do is password reuse. Like we saw previously, passwords on sticky notes is not uncommon. And in fact, I just got my new puppy, Lucy. She's absolutely the adorable thing. And I love her so much. I'm posting her everywhere. I post her on my LinkedIn so my coworkers, Marissa and Destiny, can see her. I post her on Twitter, post her on Facebook. I even do those awesome Facebook surveys that tell everything about Lucy and myself. But because I love her so much, she's also my password. And I love Lucy. Quite simple. All of this identifiable information puts in my password. But does this really happen? As a penetration tester, we come across many different password dumps. I'll see passwords like password, QWERTY, I love you, first names with a number at the end, and one of my favorites, admin, default credentials. So what we do is we like to show off Have I Been Pwned. This is an open source database that compiles all of the leaked passwords, but you can check your email, you can check your password, but again, it's up to you to make sure that your password is uncrackable, and the effort for me as a hacker is not worth it.
All right, so now let's get to cracking. On your marks, get set, stop. Yes, we actually do have to take a pause here because if we don't have the proper authorization, we should not be proceeding. But if we do, let's move forward with our first step, which is the Kali box. This is free open source made for pen testers, security researchers, and people like us. What's so neat about this tool that comes over with over 600 tools pre-built installed, and what is to our particular interest is password crackers. Step 2 is gathering a word list. Luckily enough, Kali has this for us, but we also can get them from GitHub or even generate our own. The one that we'll be using is rockyou.txt. Step 3 is the password cracking tool itself. We'll be going over 2 hash-based crackers, John and Hashcat, which both support CPU and GPU, but John was built more towards CPU and Hashcat more towards GPU. John is a lot better at cracking passwords less than 8, although it can do more, and Hashcat a lot better, greater than 8, but it can do less. Step 4 is to identify our target, but oh no, stop again. We need to ask ourselves if we have the proper permission, because if we do not, then we should not be identifying or locating anything to crack. Step 5 is to start cracking. So let's go ahead and try this with John the Ripper. Great. So we're in our Kali box. This is step 1. Fantastic, great. Step 2 is our word list. Thankfully, Kali has this lucky command called locate word list that it will output all of the word list that comes already pre-installed in our Kali box. As we can see that we see many word lists, and one to our particular interest is rocky.txt. So let's go ahead and look at rocky.txt. I have already unzipped this, and this is your first time, you would have to unzip it yourself. So I'm going to look at the first 10 contents with the head command. Here I see, unfortunately, the most common passwords, which are things like 1, 2, 3, 4, 5, password, I love you. Goodness gracious, that's pretty horrible. Let's get a better look at how many passwords are in here. As you can see, there's just hundreds and hundreds and hundreds of passwords within my word list, which is rocky.txt. It's so horrible. I'm just going to have to get this off my screen. All right. Another neat thing about Kali is that we can look at the applications. Here we see all the pre-built tools in here categorized, such as reverse engineering and sniffing, and we also see password attacks, which is to our interest. And here we find John. Great, so let's take a look at John. So we're going to look at the help menu with John-H. So let's first look at what does it take. We see that it takes in a required password file, but it also takes in a list of options, which is listed below. So let's look at one option. I like wordless. Why? Because I want to use rocky.txt. So that's definitely to my interest. Another thing to note here is that how does it take in a word list? It takes in a word list with an equal signs is telling me. It's really important to note the syntax when we're looking at the help menus. We can see a series of equal signs in here. Another option I want to look at is users. Seems pretty interesting to me. So users is able to take an a user or multiple users, or you put a dash in front to invert the check stating, look at all users but the ones that I'm listing. We also see groups here, and it works the same as users, just with groups. And you can also input a dash in front to invert the check. Another neat option here is dash format. It's really important that we specify the format so we can increase crack time. Again, this is not required, but it's highly recommended that we do. And we can also look at all the formats that John handles with dash list equals formats. So let's go ahead and pipe this into John. John dash list equals formats. Here we see a bunch of formats that John can handle. I see MySQL, I see MongoDB, I see Django, SHA-256, and MD5. You know what? And speaking of MD5, I'd actually like to try John out with MD5, but I don't have one offhand. I don't have an MD5 hash offhand. So how would I get one? So let's bring it back to the beginning of how do hashes even work. So we see we take in a plain text, we throw it into a hash function, and then we get a hash text, or hash representation of our plain text. And our hash representation of our plain text should be the thing getting stored as a password, hopefully. So I'm going to make a dummy password. I'm going to call this password winter, and I'm going to throw it in the MD5 sum. So I can see my winter is my plain text, my MD5 is my hash function, and I got outputted a hash text, which is my hash representation of my dummy password winter. As you recall, John requires that we include a password file. So we're going to have to put this hash into a file. So I'm going to do that with echo. I'm going to copy that hash, and I'm going to pipe it into a file, and I'm going to call that file target.txt. Great. So now let me make sure it's in there with cat. Awesome. I see it. Cool. Now we can test John out with our mock password file. So let's go ahead and do John -- format equals raw MD5, because that's the hash function that we know that we're working with, and our password file, which is target.txt. As you can see, that was lightning fast. John was able to crack the hash and state that it was winter, and that is our dummy password. So since we're doing great so far, I'd actually like to try out another dummy password. So let's go ahead and call this password love. Great. Still working with MD5 here. I see I get the MD5 representation of love. Let's go ahead and pipe this into a file because John requires a password file. And I'm just going to overwrite the contents and I'm going to do target.txt. Awesome. Let's make sure it's in there. Sweet, it's in there. Cool. So recall that we actually used John without a word list, but now we will use John with a word list. So we're going to look at rocku.txt and we need to find the path of rocku.txt, which is user share word list. Now that we know the path, let's pipe this into John and we're going to use the option -w to include our word list in here. So I'm going to throw in the path and I'm going to write rocku.txt. Awesome. So I have my word list, I have my format, which is MD5, and I have my password file, which is target.txt. Let's go ahead and run this. Super fast again, as we can see that John was able to crack that password and state that it was love, and that is actually true. That was our dummy password file. Sweet. So let's actually try something a little different. We'll spice it up a bit. And I'm going to look what's inside my directory here. And I see that I have a file called targets.txt. This is a file I actually made. So let's go ahead and see what's in here. So we see 3 users listed in here with their corresponding password hash. And as we can see, John likes the format that you use a colon to separate usernames. But admin looks kind of interesting, as it would in the wild due to its name. So let's go ahead and try to crack admin. But how do I do that? Let's look at the help menu. It's telling me that, oh, I remember seeing this actually, users. So I'm going to have to use -- users in my command to target admin. So let's go ahead and do that. So my password file targets.txt, and I'm going to use -users equals admin. Sweet, let's try this out. Oh, hold up a second. It actually didn't work. I wonder why. Well, we've been working with MD5 after all, but maybe it wasn't MD5. So if you're in doubt about a particular hash, Kali has a neat tool called hash identifier. Will it be able to output a prediction of what hash type it may be? So I'm going to go ahead and copy the hash of admin. And I'm going to run the tool hash-identifier. And then I'm going to throw in that hash that I just copied from admin. As we can see here, it outputted it. There's a high probability that this hash is SHA-256. So I guess it was SHA-256 after all, and not MD5. So let's go ahead and change that in our command and see if this actually works. So I'm going to do raw-SHA-256. Sweet. I have my word list. I have my format that's SHA-256. I have my password file, and I have my user, which is admin. And golly gee, we see that it was able to crack it super fast. And wait, the password was admin, just like the user name. Sheesh. Seems like someone was using default credentials. Not good. But we also see that in targets.txt, we had more than one password in here. So John can crack more than one password. So let's let John crack the rest of the passwords that are listed in my file. So I'm just going to use my word list, my format SHA-256, and my password file, which is targets.txt. Let it crack the rest. Let's see this go. Awesome. We can see that it was able to crack the remainder, which was for user target 1 and target 2. We see luck.777, not that lucky since I was able to crack it. And I also see pizza rules. I really do agree that pizza rules, but not a great password. So a key takeaway here is this command right here. John, input your word list, input your format type, and input your password file. If you're ever in doubt about what hash type something may be, go ahead and use #identifier to be able to output a probability of what that may be. We saw that we were able to use John without a word list and with a word list. We also were able to target a user. So really neat things with John. So let's move on to our next one.
So Hashcat is super robust, so we're going to take a look into the help menu first. So I'm going to go hashcat-h, pipe that through less. We're going to see all these different options. The first one we're going to look at is -m, which is going to be your hash type. You use that with a number. Then we're going to look at -a, which is your attack mode. We're going to look at combination and straight attacks today. Then, of course, the help menu is right in front of us. We also see options for -o, which is an out file. If we want to push our results to a file, we use -o. The next, we're also going to be seeing -w and -O, and we're also going to see -b for a benchmark test. We like to use -O to optimize our kernel. Now we're going to look at the example hashes that Hashcat can use. We'll see tons of these. Just going to go through them briefly, but you can see all of those. Hashcat also has a wiki space where you can see all of these, including potential hashes, all with the password of Hashcat. We're going to do a performance test with the benchmark mode. This will be hashcat-b-m with your hash type number. I'm doing MD5 right now, so that's -m0. I'm also going to optimize this kernel just to make sure it runs perfectly and as quick as possible. As you see, this speed is given for the MD5 hash. Each speed is different for each hash type, but it'll all work. I'm also going to create a new password like Destiny. I created my password as hello world. I'm going to put this through a SHA-256 sum and push this into a file called SHA-256 hash example. Just going to show you this file. And then I'm going to go to Hashcat. I'm going to do -a0 for straight mode, -m1400 for the hash type. Give my file SHA-256 hash example. And then also I like to use seclist. This is provided on GitHub. You can always git clone this, but it gives all of these different passwords, everything that you might need as an attacker. Again, I'm using rocku.txt like Destiny, and I'm also going to optimize my kernel with -O. Hashcat starts to crack, and then you see that that is cracked. Hashcat will show this right on the screen for you. But if you're ever in doubt, you can always go and view the pot file. This is going to be stored in the home directory of the user that ran it. It's a hidden directory, but it's .hashcat/hashcat.pot file. And this will show directly for you. So then we're going to show a combination attack. You'll see I have two word lists, words 1 and words 2, with super, world, and secret. And then I also have hello and password in words 2. So I'm going to run hashcat-a1, which is for combination. I'm just going to print out all of these potential combinations. This is really good if you have a website that you're trying to crack passwords, but you're not too sure what combination they might use. So you'll see that words 1 and words 2 were jumbled up together. So now we're going to do hashcat-a1-m for the hash type number. And again, I'm using MD5 for our hash example. We're going to give it our word list 1 and word list 2. So that's words1.txt and words2.txt. And this will start to crack. Given a random file. And as you can see, Hashcat has cracked that password, and it is secret password. So it used both word lists to crack that password. We're also going to use the -- show command. This will just show the password for you with the hash. So unlike the pot file will show every single thing. -- show will show just the hash that you asked it to crack. So in summary, the general rule for your syntax of the command for hashcat is going to be hashcat -a with the attack mode number. So 0, 1, 2, 4, 5, and 7, I believe. -m for your hash type. Again, you saw all of these potential hashes. You can always check the wiki space. And then also the hash file that you're going to be sending in. So again, we sent in a SHA-256 and a random MD5 hash file, which we weren't sure of. And then also your word list. In the event that you're doing a combination, you're going to send in 2 word lists. So again, -a for your attack mode, -m for hash type. Always optimize your kernel with -O. This will make sure that your computer has the performance that's needed to crack these passwords. And then also -b benchmark mode for any given speed that you want a hash to go through.
All right, we're going to start with our first scenario of the day. So welcome to the Damn Vulnerable Web Application. The Damn Vulnerable Web Application is a free and open source project on GitHub. We can go to the GitHub page right now and show you it. You can download this and put it on a virtual machine, and it will give you a legal environment to try out some new tools or try some new tactics. But most importantly, it will give you a legal environment because we don't want you getting into any trouble trying out these password cracking tools. But that being said, read the docs before using so you don't put yourself at risk. But let's get started. So how are we going to get into here? So we can try some default credentials. So we're going to try admin and the password of password and see if that works. And it does. And to show you I'm not a liar, the password was actually password. So we are going to actually change the security of this application to low so we can actually perform our SQL injection attack. There's different levels for trying different things, but as you see, it changes to low up there and it changes to low down there, just so you know when you're trying the different attacks. So this is going to go pretty quickly. This is just a contextual example. This talk is focused more on password cracking and less on SQL injection, but this is going to be a manual SQL injection just for knowing where some password hash files might come from. So we're going to try this out, and we put in that number 1, and we see that it's returning us the user with the ID of 1, which is admin, and the last name of admin. And we can see that the 1 went up to the ID variable up in the URL. So we're going to see if this application is actually doing some input sanitization on the back end. So we're going to look for ID number of 1337, or when any instance 0 equals 0. And since 0 always equals 0, if this works, it will return all the rows in this database. It's quite a small database table. There's only 5 rows, but our SQL query worked because 0 always equals 0. So we got everything in that database table. I'm actually going to go into this a little bit more since DVWA is a free and open source project. We actually get access to the code. And this is the SQL query in the SQL injection PHP file. It is a valid SQL query and it's taking the variable ID, which accepts the user input. So since we did 1337 or 0 equals 0, that is going into this ID variable. And on the bottom is what will be generated by the application, which is a valid SQL query. And that is why the database is actually returning all of these inputs for us. To go forward, now that we know we have the MySQL database, we can try to do some more enumeration and find out some more information about this database. So we can use database functions like version. So this is a SQL injection query that I carefully crafted, and we're using the version function to find out what version number this is. And this particular database is 5.1.41. So there's other useful functions you might be able to use, such as user, which will return the current username, or database, which will return the database name for you. Just find out as much as you can about the database, and it might be useful in the future when you're doing more attacks on this application. So the next thing we're going to do is use the information schema .tables. So the information schema .tables will return information about all the tables in the database. But information schema in general is a database view which contains all the information about this particular database. Most databases have them. As I said, this returns all the tables in this particular database. And you can compare like the default tables in a MySQL database versus what is actually in the database you are accessing. So users isn't a typical table that we see in the default table, so we're kind of interested in it. And we're going to use it for this next query. So we are crafting, we're using information schema.columns to identify the user table columns. And that is what this database, the SQL query is actually doing. So why do we care about the column names? Well, if there's something that looks interesting, then we can use it to get the actual data within that table. So like I said, we're identifying the column names for the users table with this particular query. I know this is going pretty quick, but it's just contextual example. So as I said, the column names are user ID, first name, last name, and then there's a column of user and a column of password, and those sound interesting to us. So our next SQL query that we're going to do is using these two column names, and we're going to try to grab the data in the user and password columns from the table, the users table. And like I said, there is, well, I didn't say this actually. There's actually tools that will automate this for you, like SQL mapping, but this is just a manual SQL injection effect. So you guys can kind of see how this is done. But like I said, there's a username and there's the password hashes. And we are going to take these out and copy and paste them and put them into a file. If this was a larger database, you probably write a script that would do this for you. But conveniently, it's already done for us. So there is username, column, password hash, and that is just a format that both John the Ripper and Hashcat will like and play nice with. So we are actually going to start off with John. And first, we're going to go into the John directory, the directory where this password file is. So now that we're here, we're going to use the John command. So we're going to do John and list the formats out, and we're going to pipe it to a grep for MD5, just so we can quickly see what the format would be for MD5. Because if you're not using this tool all the time, there's a lot of different ones that exist. So we're going to look at the raw tac MD5 option. So we're going to do John tac format equals raw tac MD5. Then we're going to use a word list or rocku word list and user share word list / rocku.txt. And then we are also going to pass in our password hash file, which is dvwa tac hashes.txt. And then I'm going to also readjust this window so you can see that a little bit prettier, but this will pretty much run instantaneously. And look, it's done. So you can kind of see that there's 4 passwords cracked, but there were 5 in our password file. And that is actually because there's duplications. So you can see the password hash for Smithy and admin are the same, which means the passwords were also the same. So we're going to do tac show to show duplicates and also prove to you that the passwords were in fact the same. But by default, John does not show duplicates. So that tac show option is kind of handy to know. So now we're going to do this with Hashcat, and we're going to do Hashcat tac h and then grep for MD5, because the Hashcat help file is like 30 pages long and a bit to scroll through. So this is still a little bit to scroll through, but it's much more manageable. So again, we're looking for MD5, and that's going to be 0. So we're going to do our hashcat command now, which is going to be hashcat tac m0. And then since this file has users, we have tac username. And then we're also going to do our password hash file and then our word list file at the end. Again, these are very common passwords, and our word list encompasses them, so it cracks almost instantaneously. And again, Hashcat does not show duplicates like John, so we need to do the tac show to show that duplication. And there you go. They format theirs a little bit differently, so they actually leave the password hash in there too, so you can see it. But there you go. You can see how quickly we can crack some commonly used passwords. So like I said, in this scenario, we logged into the application with default credentials. The username was admin and the password was password. We performed a manual SQL injection on the damn vulnerable web application. We cracked the password hashes collected from the vulnerable MySQL database. We also used John the Ripper and Hashcat to do that with those commands listed on the slide.
So now we're going to go into a potential scenario. So like Marissa showed, the damn vulnerable web application is intentionally vulnerable. There are not many systems that you'll come across that are intentionally vulnerable. So we're here to provide you some assistance as to how you would actually obtain these hashes. So first we would do reconnaissance. We're going to perform a quick Nmap scan or potentially a full Nmap scan on a system that we do have permission to access. We see that the victim is running services over 135, 8500, and 49154. Some of these are just quite obscure, but we're going to take a look at 8500. We're going to visit this URL as it's running HTTP or HTTPS. And we're going to enumerate through these directories with no restricted access, and anyone can access these. We see that an administrative directory is open, which takes us to a CMS panel for an administrator. We see that there's a known vulnerability for the specific CMS, and it allows us to traverse the directory, which will allow us to give access to a password properties file, which gives us all of the potential hashes for users of that service. So it looks like all of these are hashed, but what do we do from here?
So Chesley so graciously got us all these password hashes from the vulnerable content management system. So there's quite a few of them, 1,000 to be exact, and we are going to try cracking them with both John and Hashcat. So let's pretend we don't know these are SHA-1 hashes. So how do we do this? We can use hash ID like Destiny did earlier, and hash ID will also ingest a file. So we can use hash ID tac j, which will return to us the a hash ID for every hash in that file, and John the Ripper format. So it's saying that it might be SHA-1. We know it's SHA-1, but it's saying it might be SHA-1. And the format for John is raw tac SHA-1. So we're going to use that in our John command. So it's going to be John tac format equals raw tac SHA-1. And then we are also going to do our word list with ROCU, and we're also going to pass in our password hash file there at the end. And there's 1,000 hashes in this, and you can just see how quickly John chews through that. It literally took 0 seconds. So we grabbed this password hash file from GitHub. It was like a top 1,000 passwords used, and I apologize for some of the colorful language in there. But it's important to see the different passwords out in the wild. So we use tac show, and it will show us all the passwords cracked, and there were 987 passwords cracked. We're using the ROCU password word list, excuse me. So now we're going to use hash ID again, and this time we're going to use the tac m to identify the mode for Hashcat. Now, again, it will show us this, and it's saying that the mode will be 100, and that is for SHA-1. So we're going to do Hashcat tac m 100, and then put our ROCU word list, well, our password hash file, and then our ROCU word list. Again, it's chewing through it super quickly. These are all very commonly used passwords, and they're in the ROCU word list. And yeah, it took 0.21 milliseconds to crack those 987 passwords. So unfortunately, well, not unfortunate, Hashcat doesn't have the password crack. So we're just doing a little hacky way of doing it with word count TAC-L. And you see that there were 987 passwords cracked using hashcat as well, which is to be expected because we used the same word list with both of those password crackers. So in summary, we collected password hashes from the vulnerable content management services. Thank you, Cheslea. We cracked the SHA-1 password hashes using John the Ripper and hashcat with those commands below.
So now we're onto a Windows machine. So a Windows machine is notoriously difficult, even for the most seasoned hackers, but we're going to give it a try. We're going to do our reconnaissance. As always, we're going to run a quick or a full nmap scan. We'll see 53, 88, 135, 139, 389, and 445. These are all traditional Windows ports that are open. So right off the bat, we know that we're working with a Windows machine. We see that there's things like the domain, there's Kerberos, there's LDAP, there's a Microsoft DS. So we know that SMB is up. So we're going to identify all of the shares that are running on this specific machine with SMB map. We see that a share has read access through anonymous SMB login. So again, no privilege needed. And we gain access to this share with that anonymous login. We enumerate with enum4 Linux, also on GitHub. Please feel free to go and search all these tools. But we see all of these domain users. So we're accessing what we believe is a domain controller, which is quite possibly the highest of the highest fruit that we can get. And so what we're going to do is we're going to find juicy information. We're going to use a script called get np users, which harvests non-pre-authenticated ASREP responses from users on a domain. So you don't need to know any of this information. All you need to know is that there is a hash that is given to us from the script that we run, and we're going to now crack it. So as you can see, this is what is provided to us with getnpusers.py. I'm just going to copy this over into a new file. I'm going to call it curb5 ASREP, or excuse me, curb5 hash. We're going to then split my terminal because I want to show you both John and hashcat side by side. So I'm going to start with hashcat. We're going to do hashcat -A0 for straight, -M 18200 for the hash type number. We're going to send in that curb5 hash file. We're also going to send in my favorite from seclist, rocku.txt. Again, seclist can be found on GitHub. Please go find it. It's awesome. And then I'm also going to do John. So we're going to do John, send in that hash file. So curb5 hash, send in -- format curb5 ASREP, because that's the hash we're working with. And then we're going to send in a word list. So -- word list equals, and then the absolute path of the word list that we're doing. If you had a word list in your current directory, you didn't have to provide the absolute path. But I'm going to start John, and then shortly thereafter, I'm starting hashcat. And I've sped this up just a little bit so that you can see that mine didn't work automatically or just as quick, but still quick enough. So you'll see John cracked first, and then right after, hashcat cracked. You'll see that the password is going to be S3RVICE. Hashcat will show it directly for you on the screen. Same with John. And there you have it. You've just cracked a Kerberos hash. So again, in summary, we wanted to enumerate a domain controller for information on the users or the domain users on the domain controller. So we grabbed a non-pre-authenticated ASREP hash from a Python script. Again, we can grab that from GitHub. We ran both John and hashcat simultaneously to return a password for a service account with the password of service, S3RVICE. You can see below that the syntax for the commands that we ran.
So I know we focus mostly on John the Ripper and Hashcat in this talk, but it's just important to mention that there are additional password crackers out there. There are password crackers that use rainbow tables, which are basically databases that contain pre-computed password hashes, which means they contain the cracked password hashes. So you can enter a hash, and then if it's in that rainbow table, it will identify that particular password hash very quickly. These are CrackStation, Rainbow Crack, and Oomph Crack. There's also ones for Windows, which are Cain Enable and Brutus. If you are using Windows as your main machine to be running a password cracker, then these are ones to consider. Cain Enable in particular is a pretty beastly password cracker and has lots of additional functions. And Brutus is pretty great too. There's a password cracker specifically for vulnerable Wi-Fi protocols, and that is AirCrackTAC-NG. And then there's other ones such as Hydra and Medusa. They were particularly built for brute forcing. So if you're just trying to brute force your way into cracking some passwords, these ones might be the ones that you want to use since they were built to be good for that.
Now, let's protect ourselves with these password best practices. So number one misconception are to have short and complex passwords, but research actually shows that passphrases are much better for two reasons. Not only is it hard to crack, but it's also easy to remember. An example of a passphrase is something like, I eat kale ice cream potatoes. Strange combination, but it works. I can remember it. But do note, it's important to also include numbers and special characters. And since passphrases are so easy for us to remember, we can have longer passwords. Why? Because length matters. The longer your password is, the longer it will take to crack. But if you're still unsure about the strength of your password, you can hop over to howsecureismypassword.net. As an example of a password strength meter, will output a prediction of how long your password would take to crack. Another thing we cannot stress enough at the very beginning is password reuse. It's really important that we don't reuse our passwords. So let's put an example up. If I have my Spotify, my bank account, have the same email address associated with it, and unfortunately, perhaps the same password, and my Spotify account got cracked, well then now the hacker is going to look at all instances of where my email address matches, and which now is my bank account, and unfortunately things are not looking great for me. Another example of password reuse for me is default credentials. We get a router sent to us. It comes with a seemingly complex password, but it's actually easily searchable online, and you're at a great risk of getting cracked. I know this is a lot of information getting thrown at you, but don't worry, we actually have a solution for you.
That solution, password managers. So with password managers, you don't need to remember any password but one, and that's the one that you use to log into them. So they create strong and unique passwords for every single website you visit. It can remember anything from your driver's license number, your social security number, your address, and it can autofill all of these credentials for you. So no more writing, your first name, last name, your phone number, any of that. So they can auto-generate secure passwords just by doing a generation. You can specify the number of characters. You can specify upper or lowercase symbols, numbers, anything that's similar looking characters. And it can also prevent password spraying attacks. So like Destiny said, if she used her Spotify password also for her bank account, this is what's called password spraying. So we want to make sure that we use a unique password for every single instance where our email address or any of our credentials could be located. So this is an example of one of the password managers that you can run into. You'll see that I can generate a 24-character password at random using symbols and numbers. And when I go in and try to sign in to a database or some other system, it remembers this for me. And all I have to do is type in either my single password for that password manager or some other credential.
and some additional password manager features. Like most of them are cross-platform. So if you use a Windows, Mac, if you use Android or an iPhone, you should be able to use any of these password managers on your device. Most of them do a freemium business plan. So security extras usually are included in the paid versions. So that might be something you take into consideration when comparing password managers. Additionally, some are cloud-based versus locally hosted. And depending on your risk appetite, maybe you are doing some very sensitive work and you want to have your passwords locally hosted on your machine. Or if you're the average consumer, you might want to have the convenience of a cloud-based password manager. Some common password managers are 1Password, Bitwarden, Dashlane, Keeper, LastPass, and NordPass. See what works for you. And we can't, unfortunately, recommend a password manager, so you will probably have to look into this yourself. So overall, just remember to protect yourself. Don't reuse passwords. Utilize password managers. Use passphrases, and the more characters, the better. So ultimately, think like an attacker. If it's a low-hanging fruit and you think that, oh, if I would try to log into the system, I'd use default credentials, probably don't use default credentials. And if you want to try password cracking for yourself, make sure you're doing it in a legal environment and have authorization. We can't stress this enough. We don't want anyone getting in trouble. Thank you, and we'll take questions now.
Beautiful, wonderful, great information was shared. We see all these awesome questions coming in, and I know we only have 8 minutes to spare, so I'd like to just hand it on over to Marissa to go ahead and start working on these questions.
All right, one of the first questions we got was, what does echo tac n stand for? Echo is just a command in the terminal that will echo a string, and tac n is just preventing it from appending a new line afterwards, because we were using it to hash a password, so that new line would change the hash.
Great. And Destiny and Chislia, would either one of you want to take the next one?
Yeah, I see one here. When you find a hash, how do you know its type? So both Marissa and I use two different tools. So I use something called #identifier, where outputs a prediction of some hash types it may be. I'll let her take over the tool she used.
So I used hash ID. I think they're similar tools, if not by the same person. But like mine was just all terminal based and was able to ingest entire file of password hashes and try to identify each hash in that file.
Great. And we do have a question, would the recording be available for the session? Anyone that registered for this session automatically will get in their inbox a recorded copy of this. So that answers that.
So another question is if we're using Kali as a VM, definitely, please do not use this as your host. Kali is by all means very diverse, but it's also very vulnerable. So you don't want to ever have the opportunity for somebody to have access to a Kali host. So we always run this in a VM. So I use VMware, but you can always use VirtualBox.
And that will actually answer another question, like where can we download rocku.txt? If you use Kali, it's already in there. And I believe there are safe versions on GitHub as well. I think SecTools list, you were saying?
Yeah, SecList.
So yeah, I use SecList. It's by Daniel Messler. He's a well-known hacker, and so basically all it does is SecList has almost every single type of breach. You use it for discovery, you use it for fuzzing, you use it for enumeration. If there's so many word lists out there that you can use it for every single type of potential hacking you need to do for enumeration, password cracking, fuzzing, everything.
Are password generator is a good tool to use when you need a complex password / passcode created? I would say yes. I use password generators within the password manager that I use. you can increase the level of characters too, which is pretty great. And then you have, like, what's really important about this is like you having a unique password for each of your accounts. Because like if one is compromised, then at least all your accounts aren't compromised. And then you can change your password again.
There's also another one that's saying is if a password manager gets hacked, then everything's compromised. So with most password managers, a lot of the passwords that you put in are going to be encrypted. So even if the password manager does get compromised, all of your information should be encrypted. There have been a few that we do know of that have been compromised. So you're just going to have to Google, as we can't give recommendations outright, but look and see what those ones were. And I would recommend do not use them. We actually have a few instances where I have cracked a lot of these passwords from those insecure password managers. So, yeah.
Yeah, but it's always good to use multi-factor authentication. So if someone does have your password, well, they don't have your phone. So it's really important. We can't stress enough to use multi-factor. I see one here. What is a serious password cracking software? Can you give us an example? So I know Marissa and Cheslea both use the password crackers in the wild, even some that we talked about today.
I mean, for most instances, like John and Hashcat will get you really far. Like it really, like I said, mentioned before, there's a lot of other password crackers out there. Like it really kind of depends on your unique situation. If you're looking to use a specific software for a specific application, like I would say Hashcat and John are pretty great and will get you pretty far.
Yeah, I would say the same. 99.9% of the time, I'm using either Hashcat or John. It's very, very robust, both of them. And obviously, one of them, Hashcat versus John, CPU versus GPU. So it really depends on what type of computer or what kind of desktop you have. If you have a laptop, all of your system setup is going to determine what is the best password cracker for you. If you're using SSH, right, like I would go for Hydra. It all really just depends on the situation that you're in when you're presented with a hash. Oh, I just saw my favorite platform. So Hack the Box is something that I always recommend to people. So someone asked, can these tools be useful when working on Hack the Box machines? Yes. So I frequent Hack the Box. I'm probably there every evening and every weekend. I use these tools on probably 70 to 75% of the boxes because they are not just hidden in text files or hidden in config files. These hashes can be found when you're trying to log on to someone as an NTLM hash. So that's a Windows term, just to try to get into someone's share or get into someone's machine. So these are tools that you'll use in the wild. These are tools that you'll use in a lab on a platform. So they're not just, yeah.
And depending on what level of hack the box you have, like the retired boxes, like you can look up, different people have done different walkthroughs on them, and you can kind of see where some instances people have used these tools on the retired boxes.
Yeah.
How does one crack a password to access a computer rather than a file? I think Cheslea kind of touched on this with NTLM. Do you want to take it over?
Yeah, so sometimes we won't have a file that's given to us, and instead we'll run a tool called Responder, or maybe we'll run, something else that intercepts these hashes as Destiny's logging onto her computer. And in this case, I will take that hash, NTLM, if she's using Windows. I'll run this through crack map exec. CME also is another tool. And you can deliberately use these. Sometimes you can have access to an Etsy shadow file that'll give you access to somebody else's machine too. And you can use John or Hashcat to do this. So kind of just to reiterate, right? It's not always files that you have access to, but all of the instances on how you get the passwords are going to still result in you using a password cracker to crack them.
And there is another question. Since you were using Kali as a VM, how did you use Hashcat without errors or tac force? I didn't run into any issues running Hashcat on Kali. Did either of you?
Yeah, so Hashcat is notorious for not being willing to work. I actually just had another instance where I had a VM that I needed to do an open library that I had to download because there was a separator missing, or a separator wasn't recognized, something like that. Everything is always Googleable. GitHub is your best friend. And I've never had to force Hashcat to run. I've always been missing a library, or I've mistyped a hash file. But Hashcat should always work under the proper conditions without using force.
All right.
I think we have room for one more webinar. I'm sorry, something like got stuck in my throat, or for one more webinar. You ladies are like,
Another one.
More webinar, one more question. So, Marissa, would you like to take the last question?
I actually think we answered that one. We were talking. The question was, how does one crack a password to access a computer rather than a file? And Cheslea was talking about it with NTLM.
Beautiful.
Yeah, multiple ways.
Yeah.
Wonderful. Well, this was a fantastic presentation. Great questions that came in. Questions still are coming in. We'll be sure to get to them all, any unanswered questions, and respond to those. But I appreciate everyone's time and attention, and for bearing with me as I lost my voice. But Marissa, Cheslea, and Destiny, thank you for your time today and for providing this to the WSIS community. We really appreciate you and Carnegie Mellon Institutes and University, your strategic partnership with the organization. So everyone have a wonderful afternoon, and looking forward to doing it again.
Yeah. Thank you for having us.
Thank you guys. See y'all.
Thank you.